Take a moment to think about how much mail you received today. Newspapers, letters, emails, maybe a birthday card. Our entire life histories have been shaped by the mail that's sent to our doorstep. The mail delivery system is such an integral part of our existence that even the cells in our body have one. They're constantly chatting to each other through envelopes packed full of biological information. They're telling each other when they're healthy, when they're sick, when they need something. They even have their own form of fake news. My PhD has seen me take on the role of code breaker, deciphering these messages when the system breaks down during type 1 diabetes. Type 1 diabetes is a life-threatening condition that occurs when the body's own immune system attacks the pancreas. This leads to the destruction of the vital insulin-producing cells. In 1922, diabetic sufferers were given a message of hope because insulin could be produced in the lab and injected into the body multiple times a day to extend people's lives. So what's happening in the pancreas? Are pancreatic cells sending bad messages to the immune system, provoking an attack? Do the pancreatic cells even know what's going on? And if they do know what's going on, well, what are they doing about it? These are important questions because for decades, researchers have been debating whether or not there's something wrong with the immune system or something wrong with the pancreas. Now, collecting these messages from the pancreas has not been easy because they're nanoparticles, just 100 nanometers small. And to collect these nanoparticles in liquid, I have to spin that liquid at 2 times the speed of a Boeing 777 jet engine. But once collected and chemically analyzed, I can see that the pancreatic cells are not just hanging around. They're desperately fighting against the immune attack. They're sending potent cease and desist messages. There's a molecule on the surface of these nanoparticles that can delay the onset of diabetes because it can stop the immune attack. This is important because it furthers our understanding of the pathogenesis of the disease and explains why some people get diabetes far later than others. In the future, researchers may be able to take on the role of postwoman and hand deliver messages from the pancreas to the immune system to delay the onset of diabetes and reduce the number of years people have to spend injecting themselves with insulin.